The reason we learn algebra in the first place is to help us solve word problems. So, just like everything else, we're going to look at word problems that involve inequalities. So here's a problem that's an example in your book. Molly set her car's trip odometer, that's the thing that measures how far you're going, at 0 at the start of her trip. When the odometer showed that she had driven 16 miles, a highway sign showed her that she was still more than 25 miles from her home. What is the minimum total distance to the nearest mile that she will have traveled when she arrives home? In other words, what's the distance of the entire trip? So, as always, we begin by writing down in words what we don't know. The distance we will call x, just because we usually use x. So, the whole distance, and so now we have to go back to the word problem and see what that is. So the entire distance is x. See if we can write an equation. She's already driven 16 miles, so the total minus the 16 that she's driven. And at that point, a highway sign showed her that she was still more than 15 miles from home. So x minus 16 is more than 25 miles from her home. So she's still more than. We get the greater than. As always, we solve it. And we find out that x is greater than 41. So, to the nearest whole number, if x is greater than 41, that means it can't be 41. So, just like the closed dot. So the answer to this problem is 42 miles. I think the language. If something says at least, then that means it is greater than or equal to something. Like, in other words, if I say, so-and-so's age is at least 35, that means they could be 35, or they could be older than 35. So at least, greater than or equal to. No less than. Let's think about that one. If I have a rent that is no less than $1,000 per month, that means it could be 1,000, it could be 1,001, it could be 1,002, it could be anything that is greater than or equal to. So that's what that one is code for. The price of a book is at most $15. Okay, so if it's at most 15, it could be 15, it could be 14, it could be 13. So if I say at most, that's code for less than or equal to. If I say, I made my time in a 10-kilometer race was no more than 40 minutes. Okay, so it could be 40, but it could only be less than 40 as well. It can't be any more than 40. So no more than is also less than or equal to. Whenever you're in doubt, just take a moment back and sit back and think about what it must mean in terms of a problem. So, if someone's going on a vacation and the rent is $125 per week, 125, wow, that's really cheap, per week, plus, oh, it's a car, okay, I'll rent a car for a vacation, $125 a week plus 15 cents per mile. How far to the nearest mile can one travel if you want to spend at most $200. You'll see all of the words for this. If you want to look at the entire problem, you could look at page 470 in your text. But the question is asking for how many miles. Actually, I need to put that in here. How many miles? How many miles? And it says to the nearest mile. So, okay. So the question says how many miles. So just like we've always done, we look at what the question's asking, and we say that's what the variable is going to be. So we know that it costs $125 plus 15 cents per mile, and we're calling miles X, and he wants to spend at most that. That means no more than 200, so less than or equal to 200. So when we do this, we find out that 15 cents times X is less than or equal to 75, and that means that X is less than or equal to 500. You can check it on your calculator if you want. Okay. Here's one. The next one involves the width of a, oh, this is so outdated. The width of, okay, the width of a rectangular computer screen. So we're not even going to go into it, what it is. The width of something of a rectangle equals 20 centimeters. I'm sorry, 20 centimeters less than twice the length. Now, even though we learned about two variables and two equations, right now we're going to go back to the way that we did it using one variable. The perimeter is at least 53 centimeters. Okay, find the minimum dimensions. That means the smallest the length and the width could be if the dimensions are, if only integers. Okay, how do we say that? If dimensions are integers. Okay, in this problem we have two unknowns. We have the width and the length. And we know from way back in 7th grade, the last one mentioned is usually easiest to represent the variable. So we're going to call that one X. And the width is 20 centimeters less than twice the length. So twice the length minus 20. And we also know that in perimeter we've got two lengths and two widths. So 2 widths plus 2 lengths. And now here we are. It is, the perimeter is at least, okay? So if it is at least, that means it has to be 53 or more. So we are going to say greater than or equal to, see, at least 53. So 4x minus 40 plus 2x, which makes it 6x minus 40 is greater than or equal to 53. And that means that, oops, sorry. That means that we're going to add 40 to both sides. So 6x is greater than or equal to 93. Now here comes the part where you have to realize that you've got to do some interpretation. So x is greater than or equal to 15.5, but they have to be integers. So the smallest integer that's greater than or equal to 15.5 is 16, making the width equal to 16. This is the smallest, okay? And therefore, using that idea, oh, actually, that's the length, sorry. The length, because that's what we had x equal. The length is 16, and the width is twice that, which is 32, minus 20, which is 12. So the minimum that they could be, the length and the width could be, and still meet these qualifications is 16 centimeters and 12 centimeters. So give this your best shot. It can be a little bit complicated because there's some interpretation of your answers, but I think you're up to it.